This next video is going to be talking about molar mass and percent composition. So we'll start off with this chemical formula. I've given you one of the hardest chemical formulas because I think we can break it down to working on molar mass and percent composition. So to start off with here, I do my mole inventory. So I know that for lead, I only have 1 mole. I know that because there's no number beneath. And I want to use dimensional analysis to determine that, so I am looking for this whenever you do this work. And you look at your periodic table and recognize that 1 mole of lead has a mass of 207.2 grams of lead. So just let me go back and talk about what a mole is. A mole is a quantity that we use in science. Just like a dozen equals 12, a mole means you have 6.022 times 10 to the 23rd atoms or molecules of that element. It is a quantity. Now this is different than molar mass. The molar mass is if I had 6.022 mole times 10 to the 23rd atoms of something, how much would that weigh? That's the molar mass, one of the things that students often forget. So now let's go next to the next one. I have, because of that subscript, I know I have 2 moles of carbon. So looking at my periodic table, I know that 1 mole of carbon equals 12 grams of carbon. My next inventory is hydrogen, but notice I have hydrogen here and I have hydrogen here. If I do my actual, and my apologies, I hope that all of you recognize that this should be 4 moles. I did not change that. So for the next one, you'll notice that I have 3 moles of hydrogens, but 2 sets of 3 moles. So this should give me 6 moles of hydrogen over here, plus 14 moles of hydrogen over here. Do you notice I have 7 sets of 2? So this works out to be 20 moles of hydrogen. And to get the molar mass of that, I know 1 mole of hydrogen equals 1.01 grams. All right? So the next one is oxygen. Oxygen, again, I have 2 sets of 2. That means I have 4 moles of oxygen on this side. But over here, I have 7 moles of oxygen. There's no subscript. So that works out to be a total of 11 moles of oxygen. So I have 11 moles of oxygen here. And I know that 1 mole of oxygen is 16 grams. All right, so if I were to do my math in all of this, this of course is 207.2 grams lead. This here is 48 grams of carbon. This is 20.2 grams of hydrogen, and this works out to be 172 grams of oxygen. So now we're going to do the total molar mass, and if I work out the total molar mass, I add all of these together, and when I add all of these together, I should get a number that looks like, just doing my last calculations, I should get a number that is pretty close to 547.4, and I hope I did my math right in this one. So that's how much 1 mole of that weighs. So now let's do percent composition of, let's say, carbon. Let's say I want to know what percent of this is carbon. Well, I look here and I know 48 grams of this total is carbon. So percent, remember, is part over whole. So in this case, 48 grams of carbon over 547.4 grams of your entire element, I'm not going to write it out, but the whole, works out to be, and I'm going to pause this so I can actually do this calculation.